Screen. Okay. Can you see my presentation?
Yes.
Oh, just give me a second. Sorry. Okay. Let me move it. Okay. Yeah. Thank you all. Okay. How are you guys doing? Yeah. Thank you for again providing me this great opportunity. Good evening, everyone. My name is Youngwoo or Young-seo. I live in Toledo, Ohio, and currently working at the Department of Civil and Environmental Engineering at the University of Toledo. I'm also jointly appointed to Department of Chemical Engineering. When I got the initial invitation from Megan, I wasn't sure whether I'm the right person for the seminar series. However, I couldn't say no to Megan because Megan had already given a wonderful presentation for my undergraduate students for one of the class last year. Yeah, personally, preparing a presentation for the seminar was a great opportunity for me to reflect my personal journey and the diversity role in my career and the core values I learned working in water industry and on educational institution. Just give me a second. Let me move to next slide. So this is actually where I am. I'm at in Toledo, Ohio. So first largest city in Ohio. So around 500,000 population in Toledo metropolitan area. And I'm working at the University of Toledo, public research university, serving around 15,000 students. So in this talk, I will briefly share my background, personal journey, and what I've been doing, followed by diversity and inclusion role in my career, specifically at an educational institution. Then I will put in my 2 cents for young professionals and students who are interested in pursuing a career in water sector. So bear with me. Actually, I have a dual screen, and then the little bit big, monitor, and then my camera is located up there. So I may try to move my eyeballs here and there to see the screen and the camera, but probably I will just focus on looking at my screen right now. Okay. So this is a question I got quite a lot. Where are you originally from? And then I saw the previous presenters PPT, and then I thought it can be the slide I need to include for this presentation. So I'm originally from South Korea, and basically for this presentation preparation, I did some simple Google search, and these are the images I found from Google. Actually, so I don't know how many of you are familiar with the country, but probably you heard of Taekwondo, the kimchi, and then some Korean companies like Samsung, LG, Hyundai, Kia, and nowadays actually the Netflix show K-dramas, like including Squid Game, and the BTS. I'm not familiar with them, but I know that they are very popular. So I grew up in Seoul and earned my BS and MS degree from Sunkyunkwan University in Korea. And if you can see at the corner, actually you will find my face somewhere. So all healthy Korean men need to complete military service. So I did mine right after I finished my freshman year. And after obtaining my MS degree, I worked at the Korea Institute of Science and Technology as a process engineer. Then I moved to the United States 21 years ago and pursued my Ph.D. in environmental engineering. I have 2 daughters, Faith and Joan, and a dog named Somi, 2 cats, Tofu and Tuli. By the way, I have a cat allergy, So I need to take the medication every other day to cope with the cat allergy. Nowadays, I love to swim and run on the neighbor area, with listening to some audiobooks. And then you can see the more here. So cutting grasses is not my hobby, but I enjoy doing it sometimes, not always, sometimes, as it clears my mind. Yeah, it is brief background about me. Let me move to next slide. So these slides include the summary of my professional experience and educational background. So I joined the University of Toledo 16 years ago. Before joining UT, I worked for an environmental consulting firm as a project engineer. During that time, I worked on water and wastewater system design and water distribution system modeling. And yeah, time flies. Actually, I cannot believe that it has been 16 years at the University of Toledo. Yeah, so my interest in water, what made me interested in water? So this is some figures. My mom used to tell me that I really like to play with all kind of water for various recreational purpose. This is one of them. And I majored civil and environmental engineering, and during my undergraduate years, I had an opportunity to participate in undergraduate research on membrane system for water and wastewater treatment. It was a really exciting experience for me to see how simple process could effectively remove all the particles and produce the clean water with no turbidity. So after having undergraduate research experience, and then I decided to pursue my MS degree with membrane processes. And then after my graduation, I continued to work on membrane system, especially so-called membrane bioreactor system for the wastewater treatment and reuse. And I came to state to pursue my PhD. And during my PhD study, I delved into the research of biowalls and bioremediation of the contaminated soil and groundwater. So these are some images. So these are the membrane bioreactor system images. And then some other type of membrane system for the water treatment. And then for my PhD, I worked on biowall to treat the contaminated groundwater, and also work on the direct bioremediation of contaminant using the microorganism. So when I tried to connect dots, I realized that whether I was conscious of it or not, I've been working on so-called biofilms. So for the membrane systems, biofouling is one of the major problem that actually decrease the performance of the system for water purification. So for the membrane processes, I try to minimize the biofilm formation. But for the soil and groundwater remediation project, I was working on under the support of the National Institute of Environmental Health program. I tried to enhance the biofilm formation to grow biofilm and degrade the contaminants. So after I joined University of Toledo, I needed to think about my research at the university. And when I tried to connect dots, first things came up in my mind was the biofilm I have been working on. So specific research interests, I have some interest here. So still biofilm control in engineered water system that include the water distribution system and filtration system at a water treatment plant. And I'm also working on biological and chemical treatment for the emerging contaminants. And after 2014 water crisis caused by the harmful algal toxin in Toledo, Ohio, I have been working on harmful algal bloom control and mitigation research. Then you may have a question, what is a biofilm? So I'm not going to give you a lecture for the biofilm, but the biofilm is simply aggregates of the microorganisms. So when microorganisms grow together, they produce like a slimy glue-like material. And then those material not only help them to build the structure, but also help them to be protective against all the different chemicals. So bacteria plus the glue-like material, EPS, are basically biofilm. And it is actually within our body. And then also it causes a lot of problems. So it can cause the tooth cavity. And then if you have embedded medical devices like catheters, common infection is caused by the biofilm formation. And then chronic ear infection, skin infections are also caused by the different type of the microbial biofilm. And it also causes various industrial problems such as water distribution system corrosion, water pipe corrosion, the ship hull, biofilm formation on ship hull will actually consume the more energy. And then biofilm formation in heat exchanger will reduce the heat exchange capacity. And then food process systems are commonly contaminated with the biofilm, and membrane here also a common problem with the membranes are membrane fouling caused by the biofilm. And there are a lot of issues, industrial problem with the biofilm, but at the same time, we are utilizing the good microbial biofilm or fungal biofilm, biofilms to remove the contaminants from different sources, such as if you look at the left corner, right corner of the figure. So this is the one of the example which I mentioned before, the biofilm formation in contaminated soil that can degrade the contaminant. And then in the middle figure at the bottom, biofilm formation in the wastewater treatment process can remove the organics from the wastewater stream and then purify the water. And then left bottom figure shows the biological filtration for the contaminated air stream. So we can also use different biological filtration to purify our water. So one of the major interest area I have is basically biofilm formation in water distribution system. And then motivation is actually, we have actually aged water infrastructure. And then we have a lot of problems with a big number. So I believe many of you are already familiar with the problem associated with our aged water infrastructure. But these problems come with a big number as shown here in the slide. And then more clearly, these are the information I got from the American Society of Civil Engineer annual report for the infrastructure condition. So we have around 250 to 300,000 water main breakage per year, which can be translated into the 385 to the 822 water main breakage per day. And then we actually have estimated 6 billion gallons of loss due to this water pipe leakage. So 2.5 trillion gallons of the non-revenue water loss per year. And then American Society of Civil Engineer actually graded our system as C+. Actually, until recently it was a D, but we made some effort and then brought up the C+ level. But we all know that the C+ is not good grade, right? And then, so minimum 400 billion have to be spent over next 20 years. So we have a actually big problem, but these problems are underground mostly for the water distribution system side. So, you know, the out of sight and out of mind. So unless we have a water main breakage, we did not really pay attention and repair those aged water infrastructure. Okay, so what about the water quality? So simply you can assume what may happen in aged water distribution system. So this is the images I got from my colleague at different university. And then he actually had the opportunity to take out the old water main. So you can see This is 8-inch cast iron pipe. You can see a lot of things going on, right? A lot of accumulation. So corrosion, the inorganic precipitations, and also underneath of these corrosion and tubercles, there are lots of microbial activity going on, even under the presence of the disinfectant. So in general, for the water diffusion system, biofilm are not really pathogenic biofilm. So they are not, usually they are not opportunistic pathogen, but the concerns are associated with the pathogen biofilm. They may harbor and then enable opportunistic pathogen to grow in the biofilm matrix, because as we discussed before, the biofilm has the biopolymer. So those biopolymer, like a glue, like a material, can actually protect the microorganism embedded in the matrix. So although small number of pathogen can grow in the biofilm matrix, that those biofilm matrix can protect them against the disinfectant. And then when we have the hydraulic shear applied to the surface of the pipe, those biofilm cluster can be detached from the surface. And then detached cluster may contain the high level of the bacteria. And then they are also very resistant against the disinfectant based on our own study. So this is actually one of the example of the biofilm formation, a problem associated with the biofilm formation in water diffusion system. So we all know that the Flint water crisis, right? Yeah, so Flint water crisis, and then when you think of the Flint water crisis, and then we immediately think of the lead problem, right? Yeah, released lead, due to the improper maintenance of the water distribution system. But actually, people died actually, not because of the lead issue, but because of the bacteria, infection, bacterial infection called the Legionella bacteria infection. And then the Legionella outbreak happened due to the improper management of the water distribution system. And then, as I remember, 90 people got sick before, and then 12 people died. And then this, according to the PBS investigation, like I don't know how many of you watched the Frontline, but PBS Frontline investigation indicate that the number might be much higher, actually. So, so I came to have interest in managing the biofilm along with managing the water quality in the water diffusion system, because we have aged infrastructure, and then we do not have enough resources to replace all of them together in a given time frame. So I wanted to understand what's going on in the water diffusion system for the water quality, biological and chemical water quality. At the same time, what will be the way to improve the biofilm control in the aged water infrastructure. So that was the beginning of my new research at the University of Toledo. So still working on biofilm processes or biofilm, but try to better understand the how biofilm survive and grow and even redistribute under the presence of the disinfectant for the water diffusion system and the water quality management in the water diffusion system. And so fortunately, we received the different funding support, and then we could better understand how disinfectants like chlorine and chloramines are transferring into the biofilm matrix. And then so one side of study, we focus on removing the biofilm in water diffusion system. The other side of the study, again, similar to the water and wastewater treatment processes using biofilm, we try to enhance the biofilm formation, especially for the biological filters applied for the drinking water, potable water production. And then another main project my research group and my students have been working on is that biofilm mediated disinfection byproducts. So as I briefly mentioned before, when we try to control biofilm, we use a disinfectant. So when you go to swimming pool, you smell chlorine, right? When you open up your faucet, actually you also smell chlorine. So chlorine or the disinfectants are used to control the biofilm in water diffusion system. And especially when you have a high level of biological activity or biofilm activity, one common response we take is to apply high level of disinfectant. So to eradicate or kill biofilm, we add a high dose of chlorine, and then we apply the hydraulic flushing for the water diffusion system to remove the biofilm. But actually, biofilm matrix can actually attach a lot of organic matter, which means actually disinfection byproduct precursors through the adsorption, and also biofilm EPS, those glue or slime-like material, have a very similar chemical properties with the DBP precursor. So you can imagine, so to remove biofilm, we add a lot of chlorine, but actually chlorine can interact with different types of organic matter that include the biofilm matrix, and then we may produce high level of disinfection byproducts unintentionally. And then what we also found was that the biofilm can also degrade some disinfection byproduct like a haloacetic acid. So we would like to evaluate how biofilm actually affect the fate and transport of the disinfection byproduct in water system. So that is another major research we have been working on under the support of the National Science Foundation. So there are other studies we conducted under different funding support, like the detachment of the biofilm from surfaces, and then impact of the pipe material, like the corroded pipe material versus the inert pipe material, how they affect the biofilm formation and redistribution in water diffusion system. Yeah, and then other than biofilm research, my research group also work on the microsensor development. And then since we are located in the near the western basin of the Lake Erie Center, so Toledo is actually at the shore side of the western basin of Lake Erie. And then we know that there is a harmful algal bloom problem. So one of the study under the support of the US EPA is that we wanted to monitor the phosphorus release from the sediment under oxygen depleted level. So that is some studies we were doing in my research group. However, we actually came to kind of the switch gears to move to the slightly different area of the research. So mainly caused by the 2014 Toledo water crisis. I believe all of you heard of the water crisis. Actually, it was international news, even international news. So a couple of my friends actually sent me an email and they asked me about whether we are okay, because they saw that event, actually international news in South Korea. And then they heard of the Toledo, Ohio, and then no drinking water for 2 days, 2 or 3 days. And it was international news. And then I even got contacted by my older friend in South Korea. So basically what happened was that although we made a lot of effort to purify water and produce safe drinking water, so we had a very unique situation in 2014. So we have a bloom, severe harmful algal bloom happening in the western basin of the Lake Erie, as you can see here in the picture. And then the blooms, harmful algal bloom condition was not in good shape. So all the cyanobacteria were about to die, and then they released lots of soluble toxin. And then also due to the high wind, all the water got agitated. So water intake system took a lot of mixed water that contained a high level of cyanobacteria and toxin. So after water treatment, the finished water still contained 3 to 5 ppb level of the cyanotoxin, and which exceed the WHO guideline of 1 ppb level. So city actually basically warned the residents not to drink the water. And then we still have a drinking water, but residents could not drink the water. So it was a really chaotic time in the city and also neighboring small cities as well. So not only for the drinking water problem, so it is not just for the inconvenience. It is not just for us to get the water, but we need to get a bottled water. But actually, this water crisis happened for 3 days. Actually, made a huge economic impact on local business. Estimated the economic loss was counted around $65 million. So one of the example is that Toledo Hospital need to cancel all the surgeries. So those cancellation of surgeries cost a couple $1 million, so simply. So you can imagine all the, grocery stores and restaurants that need to close their doors. So there are huge economical impact. So after Toledo water crisis, we are more interested in the problem and then challenges around us. So it wasn't actually when we look at the what's going on around us, it was not just for the Toledo problem. So if you look at this figure, the right side of figure again, Lake Erie, and then those you can see the stars or the small circle red with a red color. Red colors are all water treatment plant along the shoreline of the Lake Erie. So there are 11 water treatment plants in Ohio and also northern Michigan that takes the source water from the Lake Erie. And then if you look at the left big picture figure, so we have the Maumee River that deliver lots of nutrient and turbidity to the Lake Erie, and then there are many small water treatment plants that directly take the water from the river, or they store the water in the reservoir and produce the potable water. And all those small utilities are also affected by the harmful algal blooms happening in the Maumee River. So following slides, actually PPT slides showcase some of the projects we have been worked with the water treatment plant and stakeholder. So we clearly noticed various need for the water research to mitigate the harmful algal bloom impact that affect the lives of the people in Northwest Ohio region. So we began working closely with many drinking water treatment facility in the region who were seeking answers to make an informed decision. So first project I would like to introduce to you is the water distribution system, water quality simulation for the Toledo water treatment plant and water distribution system in Toledo, Ohio. So, after water crisis was over, still many people in the city concerned about the water stored in our water tower and water distribution system. And then, is it still safe for us to drink the water, or is it okay for us to use the water? These were the questions many people have, including my wife, who asked me whether we can actually use the water or not. And I definitely said yes. But there was great concern, and especially many people wanted to know if toxins enter the water distribution system with the presence of chlorine, how far the toxin will transfer in the network. And then which location is a vulnerable location? And then what will be the decontamination method we can take? So we cannot actually inject the toxin to the real water distribution system. And then what we tried to do was that we try to do the water quality simulation using the different experimental data and a simulation program for the water distribution system. And then we could actually change the other condition, for example, like a pH of water, how that lowering the pH will increase the reactivity of the chlorine. So how that will affect the toxin decay in the water diffusion system? What about the flushing of the hydrant? How will affect the water diffusion, the toxin level in the water diffusion system? So from the simulation and based on the experimental data, we could provide some answer, although it's not perfect condition, perfect example, really identical to what happened during the 2014 Toledo water crisis. We could let the city officials and engineers know this is a vulnerable location. Fortunately, only near the water treatment plant. The houses near the water treatment plants are affected. And then actual toxin level monitored during the event. We could see some actually good simulation results matching to the few measurement located in the water diffusion system. And then for the city of Toledo, under the support of the Ohio Water Development Authority program and National Science Foundation support, we could actually help the city of Toledo to evaluate their new GAC-based biological filtration system. So city decided to install the new ozone pre-oxidation system with the improve the GAC biological filter system. So ozone system alone, $50 million city need to spend, and filtration system improving and replacing all the filtration system, another $50 million. So city of Toledo spent over $100 million to improve the existing water treatment plant and actually be prepared for the toxin and harmful algal bloom. So before installing the new system, we work closely with water treatment plant and actually conduct their pilot testing with them. So we can actually evaluate type of the GAC media, how those media affect the filtration rate, and also turbidity and TOC removal. And also, we also could actually monitor their long-term performance of their filtration system for the different parameter. And then other small utilities that experience the harmful algal bloom associated problem, those small utilities, especially that utilize the reservoir, they actually apply the algicide before there are severe harmful algal bloom in the reservoir. So especially we have been working closely with the Bowling Green and Defiance water treatment plant to monitor the algicide impact on water quality. That include organic matter and organic matter changes before and after algicide application, and also how those algicide application affect the microbiome in the reservoir. So we can actually provide the in-depth analysis for the water treatment plant so that they can still have the understanding of many different reactions going on in their reservoir, and also they can make the changes and improvement for their algicide application. And then this slide shows the one of the current project. We are working with the city of Salina. So as you know, the algae cells are not settling down well. They are not settling down because of the low density of the cell. So to make the algae settle down, we need to use a lot of chemical. But Salina that takes the source water from the Lake St. Mary. The Lake St. Mary actually experience harmful algal bloom almost throughout the year. So they would like to improve the removal of the algal cell using the dissolved air flotation system. So dissolved air flotation system utilize a tiny air bubble that make the particles and algae to aggregate and float to the surface, and then the water process can skim them off from the surface of the water. So currently, we are helping them to optimize their chemical treatment and chemical dose to enhance the performance of the DAF system for the cyanobacteria removal. And some other studies we did include biological treatment of the toxin. So we know that we always have a biofilm formation in filtration system. So we are really interested in engineering those biofilm composition in the filtration system. So can we actually enhance the performance of the filter for the cyanotoxin removal? Can we actually utilize some good bacteria to degrade the cyanotoxin? So that's the another study. We cannot add any bacteria to water plant, as you know, right? Especially Tony, who worked for the City of Cincinnati, water work. But there was some discussion how we can actually enhance the performance of the filtration system for the emerging contaminant removal. So so these are some slides for my research group and also students. So conducting community serving research that directly impact the lives of people is really meaningful effort I had. It brought many positive changes and improvements in the quality of life for individual and community around me. And also I noticed that I grew up a lot directly working with many industry people and water utility people and help them to make an informed decision. At the same time, I could see the growth of my own students who actually need to interact with the utility engineer and also community to provide the meaningful research data. So I got a question for this presentation. What is the highlight of your project? What is the highlight of your career? So I can, I don't know whether this can be highlight, but I feel very proud that what I'm doing can provide the great support for my community and people around me. And then also, as you can see here, I have the students and researchers with diverse background. So a diverse team we created together brought a lot of creativity and productivity to address the various problems associated with the water management. So yeah, this is kind of the so-called highlight slide for my achievement, as you guys asked me to present. Yeah, so regarding the diversity and inclusion, I briefly mentioned that the diverse team with a unique background and also different characters can create the a lot of the energy. At the same time, they produce a lot of the outcomes from the efforts we are making. So based on the question I got, I had the opportunity to think about the diversity and inclusion roles in my career. So actually, this is a slide I got from my training at the university. So, and this is really highly used slide for all the diversity and inclusion discussion. So first, I'm not an expert on diversity and inclusion. However, as I understand, diversity is everything that make people different, as you can see here. Make people different from each other, like economic class, educational level, not only the race, all these factors make us different. And all these factors, I think, work together to inform how we can encounter or encounter the world. So I don't know, kind of so many different ideas. But for me, especially who is working at an academic institution at a university, I think diversity is the incorporation of these differences to enrich learning for students. So all at the University of Toledo, not only University of Toledo, many academic institutes really encourage or emphasize the diversity and inclusion. So we want to embrace the many things in life that make us different. we also welcome the diversity of people in the community, and we want to provide opportunity for all participants in the life of the university by each of its members. Yeah, this is actually information available for the University of Toledo, what kind of effort we are doing. There are a lot of other information available at the Office of Diversity, Equity, and Inclusion. And what does it mean, actually? I thought about what does it mean. Actually, I even got a training for me to teach my freshman students. So what does it mean? And then I thought about the university I'm working at right now. So, and then I also thought about my students who is taking my classes and then who is attending the university. I believe this principle will be applicable for all the academic institutions. So academic institutions can be great places to learn and understand differences, and as well as to practice supporting diversity and inclusion. So you can see many faculty members with diverse backgrounds. So I'm from South Korea, and then my colleagues are from India, Czech Republic, or China, all different countries around the world. And then also student population, student bodies. So we have many students from Ohio, but we also have many students from all different countries. And then in the academic institution, I can see that students are great asset. What does it mean, actually? Students can take all different roles. So they do not need to be simply a student, but they can be mentors and leaders for groups and organization. And then actually students are already taking a role as a leader. So for the many different organizations. So and then I thought about all the changes we have. So University of Toledo engineering program I'm working now. We have a co-op system, and then usually students stay a little bit longer to complete the 3 mandatory co-op. So, but still they graduate in 5 years, and then once they graduate from university, and also my graduate students, once they finish their graduate study, they will be somewhere, right? They will be, in company. Most of them are working for government or the private sectors. So now they can actually, through the diversity and inclusion experience, they actually enriched in their college life. During their college life, actually, they can actually bring same lessons and principle to their workplaces, and then they can change their, not only change their own campuses, but also their workplaces and community they are involved. So I noticed that it is a really great place for us to help the student learn the diversity and inclusion, at the same time practice those principles during their college life. So practically what we are doing at the department level, this is the few examples we have. Again, I don't mean that we are doing wonderful job and that everybody need to follow what we are doing, but the few examples I can share with you. And then again, this effort we are making together as a team. So we try to provide students with the opportunity to serve others and raise students to be leaders. So they can be freshmen, sophomore, junior, senior, different level of students, but we are encouraging them to take the different role, such as actually we have a student mentor program for freshmen. So junior and senior students, they don't get any money, by the way. They are serving this program, but we give them at the end of their semester or the end of the year, when we have a small party together, we acknowledge their work and then give them small gift, Amazon gift, mostly. But we have a so-called student mentor program for freshmen that these junior and senior students actually help the other freshman students as a friends and as a mentor. So while helping those freshman students, actually we definitely saw the growth of this young men and women as a leaders in this academic community. And then we also strongly encourage our undergraduate students and graduate students to participate in various outreach activities, like a K-12 outreach activity for the underprivileged student. And also we have an open house. We need to host parents and families, and then helping those various outreach activities. I can sense that their students have a little bit better understanding on the diversity and inclusion, and then they also find the great role to support the diversity and inclusion through this participation. And then and some other things I want to mention here is actually for the graduate program, we are having a lot of international students. Basically, most of our graduate students are from other countries. So that means we have diverse population and diverse background. So we try to encourage those international students and our undergrad students to work together. So when they work together for different class or the projects, actually they have a better understanding of each other. And then especially if you can see this picture for the undergraduate students who are working in the lab, they actually interact with most graduate students and the international graduate students. Actually, they become friends while they are working together, and then have a better understanding on other countries, other people's culture, and then their background. And also we try to cultivate and support the international students through different group activities so that they can have the feeling that they are belong to a community at the university. Okay, so the last part I would like to share with you is actually a few lessons I learned while I'm pursuing my career in the field. I know there are some graduate students and undergraduate students in this meeting. So these are the lessons I would like to share with you. So I really like this picture. So I grew up watching NBA game in South Korea, 1990s, especially King Michael Jordan's era. So can you see the picture? 1990s, actually there are a lot of physicals, so physically tough games. And then I saw this picture. So now actually you can see the finger, and then there is less physical interaction. So why I'm showing this picture to you? I have been in water kind of career. Let me think this way. I started my graduate school 1999, and then it has been quite a lot actually. Many years I have been working in a company or the research institute, and now in the university. I felt like the things are changing a lot, and then how can I say? Things are evolving over time. So what we consider standard practice or the set of rules in an early stage of my career may no longer no longer be applicable, or maybe changes significantly. I believe many of you feel this. I don't know whether you agree with me or not. So things are changing, evolving. And then also I felt like the different expectation. I feel like I'm doing the similar work, but the expectation and the way things are working changed a lot. And then another figure I'm sharing here is actually sometimes I'm asking a question, what I'm doing actually. What am I doing now? And then especially my career as a teacher and a researcher at the university. I've I'm in the academia. At the same time, I feel like I'm running a small business. So I need to support my students both mentally and financially, which means that I need to bring right proposal, bring funding to support them. Otherwise, actually, they cannot, stay in this country. And I need to work with the students, and still I need to teach them and then mentor them. And I also need to work on the balances for the budget, and then need to work on sometimes receipt and repair of the instrument. And I need to share my vision with the students, and then also direction for the lab. And then I also need to meet people to promote the collaboration. It's just like running a small business. Um, so why I'm sharing this? Actually, I feel like the things are changing, and then I have the all the changes and varying ideas, and also new challenges one after another continuously while I'm pursuing my career in water industry. But there are few core values I personally sensed, and then also thought it will stand continuously. So first core value I personally learned is that we need to create a team rather than just a group. So actually, it is a little bit shameful that I have the website, and then it has been down for a while, but actually the website had the source group, or so I kind of the promoting that we are the group research group, but actually recently I'm learning more and more that the creating a team is really important. So difference between team and group, I believe we all know that. So team has a shared value and core value and vision together. So it is essential for us to establish shared core value in our workplace. And also as a team, I learned that it is really important for us to recognize and acknowledge each other's work, and each other's work is important. So there are many challenges, and then I can tell you that I had a problem last night actually. When I met some students, and I can see the issues and challenges in the lab and in the classroom setting, especially when we have the team members with the diverse background. We have all different upbringing and personal experience. It is more difficult for us to create a team, but again, it is really important for us to create a team, not a group. So that's a lesson I'm learning even now, how important to create a team for the successful project, or meaningful and joyful work environment we would like to have. Second one is actually lesson. Sorry, that may sound like a nagging mom to my students. So saying this kind of the very mundane stuff to students. But recently I'm also learning that do not judge a book by its cover. Actually, actually it was actually I put a small picture here. The book I recently read some part, and then also listened through the audiobook. And then one of my friends, actually, he's a doctor, and then he actually recommend me, did recommend this book for me, actually. So when I look at the cover, actually, it doesn't look that interesting. Like Emperor of all maladies. So a biography of cancer. What does this mean, actually? So I was a little bit hesitant, but at the same time, I got an audiobook from a library, and then I will try to read some book, and then also mostly will listen to the audiobook while I'm running. And I also thought that if this book does not, if this book is not interesting, then I will recommend very boring book related to the water treatment to my doctor friend, and then he can suffer the same way like I do. But actually, this book was a wonderful book. Personally, I enjoyed a lot, although I don't have a medical background. As a one who actually had a mother who with a cancer for many years. So this book actually was really good for me to understand what happened while we are trying to cure people who had cancer. At the same time, all those kind of the brave patients who actually fought against the cancer. So so what I want to tell you is that many times, we have a prejudice, so we just think that we know a certain group of people, and then they will act like as we expected. And then as I understand, this is called the implicit bias, right? and then but once we have a little bit more open mind, and then I realized that we can see the people differently, and then we can also see the value. So one of the example besides this book example, I have an undergraduate student, and then when I try to hire that undergraduate student, I actually discussed with the other faculty member because I wasn't sure whether the student will be a good fit to my research team. Simply knowing the person's his and her GPA, I was really hesitant to hire those students. But actually, those students turned out to be a blessing for us, actually. So students really shows their excellencies in research and managing their project. And then all students and me, I were blessed by those undergraduate students. So lesson, I also have a tendency to judge people based on how they speak, how they look like, but actually I'm learning continuously that I shouldn't judge a book by its cover. I shouldn't, judge or have a prejudice against the people based on how they look like and how they speak. And then lastly, again, sorry that again, you're very well-known information for all of you. So our journey of 1,000 miles begins with a single step. And then another the good quote from Mother Teresa: "Be faithful in small things, because it is in them that your strength lies." So I want to really talk to my students and junior engineer that every learning opportunities we have, no matter how small, contribute to our overall growth. Yeah. So for students, we can approach, students can approach their studies, and also junior engineers can approach their work with a more positive and proactive mindset. So to achieve, we want to achieve good things, and we want to achieve great things. And for students want to get a degree, bachelor or the master degree. But I personally, I learned that every small opportunity, no matter how small they are, really contribute to my personal growth. And then I believe it will also contribute to all of your personal growth. So yeah, so really significant accomplishment, I believe, begin with a simple and initial small action we can take, small step we can take, and these small steps will bring us closer to the larger goal we want to achieve. And then lastly, personally, it really applied to me. So there are many opportunities, and then I was a little bit shy, actually. I don't know whether people will accept me, and then I don't know whether the proposal when I start my career at the University of Toledo, proposal, my clumsy proposal, how it will be accepted by really well-known researchers. And then I wanted to give up initially. So because I thought I'm not really enough to generate the really good proposal or the good research article. But actually, I got a lot of encouragement from my friends and family members. And then I basically tried. And then basically knocked the door. And then later I realized that, many doors were opened for me because I simply made the humble move, knocking the door and kind of seeking for the opportunity. So I believe I talked to my students and also high school students who visit the university to meet faculty and see the campus. And then whenever I have an opportunity, I just share this verse from Bible, knock and the door will be open. So I believe many students here and then junior engineer or even senior engineer and myself, we humbly seek the opportunity and then with courage, knock the door and then we hope to see many doors are open for our career. Yeah, so thank you all for your time and attention. And I have wonderful students. Actually, we always call as a group. So now we are calling ourselves as a team more and more. And then these are the funding agencies who accepted my humble proposal and then provide us opportunity to work with the many water utilities around us. Yeah, thank you so much for your attention. Yeah.
Thank you so much, Dr. Suh. We really appreciate your time today. I wanted to open up the floor. If anybody has any questions, feel free to come off mute and ask them. You can also put them in the chat and I can read them out loud. I will start out. I had a question that came up just to go back, Dr. Suh, when you were talking about emerging contaminants and how you were starting to consider emerging contaminants. And then you talked about the possibility of disinfection byproducts.
Mm-hmm.
Have you or your students talked about some of the upcoming PFOA or PFOS regulations and like any concerns about additional phosphates that utilities will be using?
Yeah, actually, now all the water research and then the water community focus on PFAS actually. So we are really interested in understanding the fate of the PFAS, especially through the water treatment train, and some research idea we have, but we did not actually focus on the PFAS study recently. So we are planning to start a small experiment related to the PFAS. But when we attend the conference, actually when I meet the many utility engineer around us, we have a great concern over the PFAS because of the level we are trying to control is way too low. At the same time, that there are very limited methods. Actually, most of the studies focus on the absorption by the carbon, as we know. So utility engineer and superintendent I met near the Toledo area, and those whom I'm collaborating together, they are really puzzled what to do actually, because the cost-wise is so expensive to lower the regulatory level. At the same time, concentration is so low actually. And then there are other issues. For example, like one of the utility I'm working together, they have the concern over GAC cost, not the PFAS, because they don't actually detect the high level of PFAS, but the GAC cost actually increased almost doubled, because a lot of demand for the GAC for the PFAS control. And then you know that the many small utility that do not have advanced oxidation processes implemented, many of them strongly or solely rely on GAC filter to polish their finished water. like a great Cincinnati waterwork, you guys have a humongous GAC system, a GAC filter, but still to polish the water to lower the disinfection byproduct. Like a water utility, a small utility near the Murray River, I'm collaborating together. They have a lot of organic, and when they have a bloom, lots of algal organic matter released from the cyanobacteria, seasonal organic matter because they are getting water from the river. And then they need to lower the disinfection byproduct, which are regulated, and they need to meet the regulatory requirement. But it becomes very challenging, even like buying the GAC, which become a little bit more expensive, much more expensive than before. So those are the little bit different concern, but yeah, still along with the PFAS. But regarding Tony, your question whether I'm working on any PFAS related research right now. So the BioLab right now has a little bit limited capacity to explore the PFAS, but we have a collaborator and also colleague at the university who are working on developing new methods to detect the PFAS and also try to mitigate the PFAS impact on health, along with the water treatment optimization. So I personally haven't studied any PFAS, and then when I attend the conference, actually nowadays, last year, the WQTC conference in Cincinnati, almost like 70% of the presentations were about the PFAS. So there is not many other talks. So it is good for us to work together. At the same time, I believe there are still other important issues we need to still address, and then also help the many utility to cope with those problems. So I wanted to jump in the PFAS bandwagon, but I haven't done it yet. Yeah.
I saw in the chat, I'll just share I saw a couple of your students chime in. One says that they are it says we are proud to have you as a mentor. I think that speaks a lot. Yeah, I think that speaks a lot to you as a professor. But speaking of that, you talked about it's really important for your students or potential engineers or those leaving to go into the profession to create a team instead of being in a group. We had one audience member share that they are just now entering into the field of study of environmental engineering. And so other than creating a team, do you have any advice you want to share as they pursue that path?
Oh, okay. You mean so let me repeat the question. So beside the team building, what other important factors or the effort we need to make for the successful career? Or what, did I understand properly?
So one of the audience members shared that they were applying to both Cincinnati and Toledo to enter in the environmental engineering program. And so any advice you think they should hear as they
okay. So I meet freshman students, but now this semester I'm mostly working with the junior and senior students, some sophomore students too. So this slide actually I shared, actually many times when you start your new career, actually you can be a little bit overwhelmed. There are so many things you need to understand. Actually, I was in that position when I joined the University of Toledo 2008. Actually, I can share one kind of example a little bit. Actually, my wife still talk about it whenever she has a chance. Actually, my first proposal I developed as a principal investigator was for the National Science Foundation. It's early 2009, and I wasn't that confident in what I'm doing actually. And if you see the acceptance rate of the proposal in NSF, it is less than, although they claim that around 9%, it is less than 7% when I served the review panel at the NSF. So when I started preparing my first proposal, I couldn't finish it on time, almost like it's one night before the submission due, and then I cannot submit. University of Toledo needs to submit on behalf of me. And then I didn't complete my proposal writing. And still I need to write a page. And one of my colleagues at the time thought you just try, chances are very low. That colleague already told me that because they are the good proposal, people review the proposal several times, and then you are competing really famous professors in the field, and you are rookie. You are the beginner. So if you want, you can try, and then probably you may revise it later and then submit later again. And then I was thinking that if I submit a very poor proposal, and the people will think that already probably have a bad impression about my proposal, and then next time if I submit something, it may not be well accepted. So that's also what I heard from my colleagues, so senior professor. And then that night, the night before the submission, and then I was really struggling, and then my references in EndNote are all screwed up, and then I do not have a time to actually polish everything. And my wife saw me struggling by myself, almost pulling my hair in my home office until the over midnight, and then she said, "Yeah, just do your best and then submit it. Depending on our case, God's grace, depending on God's grace, and then just submit it, and then just try it, and then you will learn something." And then that time also my wife offered that she will fix all the reference problem I had. So she stayed with me almost whole night and then fixed all the EndNote improper references, and then she fixed it, and then she gave me the reference file, and then she still talk about it even now. So there are again the small opportunity, and then for those students who start their career in the industry, or students who just joined the university to pursue the environmental engineering, again you can be overwhelmed by many things. But I encourage it. I don't mean that I have a good experience, but I encourage all of you, including myself, that we can be a little bit more brave, and then we can actually try. Although we may fail, although we may not get the result we would like to get, but we can still try. And then those small efforts we made will build us up continuously and will lead us to the different place. So you may be interested in that proposal I submitted. Struggling a lot actually. So I barely submitted the proposal, like University Research Office submitted 10 minutes before the submission due, and I barely put all the information, and then I didn't have a great expectation. But again, I believe my proposal was not that great, but somehow the reviewer really saw the value in the proposal, and then actually awarded the grant. Actually, NSF awarded me the grant. So that's another reason why I encourage my student and myself actually continue to make small effort and then knock the door. Although you may feel like you will fail, and then but if I didn't submit the proposal, actually I know that I don't have any opportunity to get the awards. But at least actually with a lot of encouragement from my wife and then my friend and even my daughter. So I just submitted and then knocked the door, humbly knocked the door, and then somehow the door was open. So those freshmen, environmental engineering students, I encourage you to knock the doors of the professors, knock the doors of the offices, student organization offices, and then meet people. And then many opportunities will be open for you. And then those junior engineers, knock the doors of the senior engineer. So sometimes they look very scary. And then project manager, and then ask question, and then ask necessary help, and then many things and opportunities will be open for you as well. And then do not hesitate and to ask some help from those people around you. They are there to support you and to help you to grow in their places. Professors are at university to support student growth. Senior engineers are at the companies and then supporting the junior engineers to grow, right? So a little bit courageous, and a little bit more courage, and then knock the door. And that's the only advice and I can actually think about. Yeah.
Yeah. Thanks, Dr. Suh. So I just want to say that your presentation was awesome, and we really appreciate you taking the time to share with us your journey, your story. You mentioned the highlight of your career, and I will say that we all have heard of DEI, diversity, equity, and inclusion. Well, now everyone's starting to add the J on the end, so DEIJ, and that J stands for justice, and environmental justice is very important. And you talked about how the impact that the highlight is the impact that you and your students have made in that environmental justice. And so I really appreciate you sharing that. And thank you again for speaking to us today.
Thank you for having me. Yeah, I hope I didn't talk too much actually.
No, you're great.
Yeah.
Thank you.
Yeah, thank you so much. Yeah.
Absolutely. I will say that this presentation has been recorded. So for you and the audience members, if you want to share it, it'll be on our YouTube channel in a couple of days. Also want to mention that on November 9th will be our next speaker series event. And so we will hear on the 9th, we will hear from Anil Tangorala, the Director of Water Resources with MS Consultants. So again, thank you all so much for joining us today and hearing from Dr. Suh.
Yeah, thank you so much for having me. Yeah.
Absolutely. Everyone have a good evening.
Bye. Good evening. Bye.